This Pizza Tuesday item was great. Thanks for making them.
Well, I have 2 more orders here. Where do you want them? Just impale them on your horn? Will do.
I'm stumped by this crossword clue. 3 letters, starts with T.
What's the clue?
It says this season of the Bug Hunters Café is made possible by Softerific, Mouseplow Media, and Manning Publications.
Wouldn't that be season 2?
Oh, 2! That fits. Thanks.
Hello, Bojan. Something smells good.
It's a lie.
It smells like pizza.
It's not the pizza.
It looks like pizza to me.
It was a pizza, but Unicorn put pineapples and anchovies on it.
On one?
On all of them.
Let me tell you, the ANSI committee over there is very displeased with theirs.
Oof, that's a long way from the standard pepperoni and mushroom. I mean, I like pineapple and all.
Keep your voice down. The committee is currently drafting up a stern document decrying pineapple on pizza.
The Unicorn keeps changing all the orders. He insists pineapple and anchovies are the best.
I wonder what Marco Faella is going to say about that. He teaches computer science at the University of Naples, so they have strong opinions on what is a good pizza. They would know.
Oh, cool. I've been reading his new book, Seriously Good Software, which is all about writing high-quality software through iterative improvements.
Speaking of, hello, Marco. We're over here. Have a seat.
Hi. Thanks. How are you doing?
We're doing pretty good. Can I get you anything to drink? It's on Softerific and Mousepaw Media. They're the ones who sponsor these chats, so you can have anything you like in existence or non-existence.
Great. I think I'll go with just some tea. Yeah, boring tea.
All right, and I would not recommend the pizza today or whatever this is.
Why?
It's all pineapple and anchovies.
Oh, really?
Yeah.
Come on. Nah, that's terrible.
Yeah. We're going to have a small war with the ANSI committee if we don't do something about this. I'll get your tea. And usual for you, Bojan, decaffeinated espresso with a hint of rainbows.
Yes.
Okay. Now, I think they have some enthusiasm sprinkles back there if you want that on there this time.
Yes, I would love those.
All right. I'll get that for you both. I will be right back.
Yeah.
Marco, I have a bunch of questions for you.
Oh, really?
First of all, your book is called Seriously Good Software. Now, I don't know a single person that said, I'm not writing good software. Everybody is writing good software, no matter how horrible it is.
Yeah.
So I'm going to assume you have some metrics about how you can tell that your software is not only good, but it's seriously good.
Yeah, I have like a magic trick. And if you know this secret, then maybe you can write seriously good software. Want to hear it?
Yes, I love magic tricks and I love software.
Okay. I think the magic trick to write seriously good software is to be aware that there's many different ways to write the same piece of software. Even a small unit, which is what I usually deal with as an instructor, as a professor, like I usually deal with small pieces of software that students write. So even on a small unit, there's many different ways to write it to achieve the same goal. That's what I try to teach my students and what I try to teach in the book. And when you start to be aware of all the different possibilities, then you can pick. Maybe you won't pick the best one, but at least you won't just pick the first one that comes to your mind. I guess that's the trick.
That's very, very suspicious because I know from pull request there is only one way to write a good software. Every pull reviewer can automatically tell you this is a bad way to do it. Write it like this. This is how it should be done.
It's not supposed to work like that.
Here is your tea, Marco, and your espresso bouillon.
Thank you so much, Jason.
Yeah, I have encountered a lot of that where code reviews get so subjective because, and I think I'm even guilty of this. I think we're all kind of guilty of this. Is we come into a code review and go, well, this is not the way I would have written it, therefore it must be wrong. And we confuse our opinion with objective reality. How can a software developer get out of that trap of confusing their own way of solving the problem with the right way to solve the problem?
Oh, that's tricky, and probably I don't think you can like solve this problem 100%. But to try and get a broader perspective, I think one way is to read more code, like read, for example, read well-established libraries. They usually have very good quality, very good standards. For example, I teach Java usually, and it's very instructive to take a look at the source code for the standard library to get a feeling for other styles, other people's styles, and of course that's very robust code that's been reviewed many times and tested and checked. So that's definitely useful to get a better perspective on different styles. And then, unfortunately, as many things in programming, I think it's a lot to do with experience. Although, yeah, I have to say, maybe with more experience, I mean, if you're not careful and you don't make an effort to stay open-minded, with more experience, you might also get more fixated on your own style. And so, yeah, it's really tricky.
It's interesting you bring up reading code too, because just the other day we were talking to Faella, and she was talking about the importance of reading code. She even suggests starting code reading clubs and a lot more time deliberately reading code and learning how to read code better.
Yeah, I think that's a great idea. I was considering copying this idea from her as well.
And you mentioned standard libraries, but what other ways do you have for finding out the good code base to study? Because, I mean, for book, it's very easy. You have very established canons, like these are the books you should read. And during the high school, university, you get even more books to read about. Nobody does that for code bases. So how do you find those?
Well, standard libraries in any language are usually one of the best places where you're pretty sure to find good quality code. And apart from that, I don't know. Yeah, I think there's people out there. I think I've seen around on the internet people doing what you're asking, which is like curating a selection of code bases. Like they don't write it; they're just curating a list of good code bases. I think I've seen it somewhere, but I wouldn't be able to tell you like on the top of my head.
Yeah, no worries. We can use Unicorn Magic to find that out. And I have another question for you, because from my experience with university, your style and approach to programming and teaching people about how to solve problems is there are multiple ways to solve this. There's not one best way, but your solution is going to modify itself depending on requirements. How do students react to that when you tell them there are multiple solutions and they're all good in different scenarios?
Yeah, well, so first of all, I try to teach it pretty much the way you're describing it, but I have to say, in my experience, it's quite rare to see this approach in university because we have very vertical, very focused classes on different topics. So in a class on algorithms, you put all of your attention into the complexity and efficiency of your algorithms, and that's your only concern in that class. And then you have a software engineering class where your concern is about the overall architecture, pretty much, and relationship between different modules and how you organize your large system, and so on and so forth. Whereas what I'm trying to do is well, as you know from the book, is to connect these different concerns and contrast them. So yes, you care about efficiency, and there's different ways to measure efficiency. You can have speed, and you can have memory occupancy, memory footprint, or you can have network bandwidth requirements, and so on and so forth. But at the same time, you also have testability, the ability to test that class, that unit, and you have readability, which affects how your code can be maintained, or how easy it is to find and fix bugs, and so on and so forth. And so what I'm trying to do in my teaching is to put everything pretty much together, compare these different requirements, and above all, try to teach students that as much as possible, they should keep like everything in mind. I mean, the ideal mental position for an experienced programmer is to keep all of that in mind, all of those concerns, and also balance them according to the specific context, according to the product that you are developing. Probably in some products, efficiency is more important. Say you're developing a video game, for example, then efficiency is probably very important because you don't want your game to lag. And readability is less important for a video game because that's probably a product that's not going to be used for many years, because there's going to be new games after that. Whereas in other contexts, you want to have a very robust code base, then you should have very high reliability, very high readability, because you need to maintain that code base for many years, and you care less about efficiency and other qualities. And of course, you were asking how students react, and it's hard for them to capture that, to switch from basically they're focusing on getting it right. So they're focusing on finding at least one way to do it. So for them, and I'm talking about undergraduates, maybe they have been programming for 2 years at that point, 3 years at that point. They're still struggling to figure out the language. They're still struggling to find at least one way to complete the assignment. So it's a bit hard for them to grasp all of that when they are concerned with finding a single way to do that. When they already struggle to find one way to do it, it's very hard to imagine that there's many different ways and that they perform differently on different software qualities.
So I know that I often have a lot of these things bouncing around in my head. I've even had times where I was working in a project that needed to have both a low memory footprint and be reasonably efficient. And I found myself trying to tune a particularly critical part of the code. And I realized that I had spent the last 10 minutes trying to figure out how to avoid using the CPU and the memory, and had to pull myself back from the brink of insanity. But it sounds to me from what you're saying like one of the most important things if you're going to write seriously good software then is to understand what the actual needs are of your project. Does it need to be minimizing network resources? Does it need to have a low memory footprint, or does it need to be more repeatability in the testing? So figuring out those requirements early then you would say is part of this?
Yeah, I think it's part of it, and above all, to be more explicit about, like from a management position, from the designer position, from people who are designing these systems, I think it would be beneficial to be more explicit about the balance that they expect from the software qualities, since everyone has deadlines, so you're not going to get the best of in every direction, in every axis. So it would be better to put these constraints forward in a more explicit way.
So you mentioned multiple bands, and you've mentioned a couple of them, and I've looked over the table of contents. This book's still sitting on my shelf to be read soon. But if you could, would you mind just kind of briefly covering the bands that you go over in the book? I think you said there were 7 of them.
Yeah, I think so. It's been some time, but probably. So yeah, I focus quite a lot on efficiency at the beginning of the book, and 2 chapters. So basically, the book is structured like this: you have a chapter. Each chapter deals with a different software quality, and so the first 2 chapters are about those 2 kinds of efficiency that we just mentioned, which are speed and memory footprint. And so yeah, just to go back to the structure of the book, the idea is to have a single, very simple example, single class, which is represents water containers, where you can pour water and then you can connect containers between them, and water will flow and distribute itself among all the containers that are connected to each other. So I take this example, and then I start with middle of the road version, which intuitive first draft. And then in every chapter, I try to optimize a different software quality. So for speed, I compare different data structures that you can use to represent those connected containers. And then those are related to graphs and graph algorithms. And also trees, by the way. Yeah. The most efficient implementation turns out to be based on trees, actually. And then I switched to memory footprint. So there I have some fun with low-level representations. So even like bitwise operations, how to push your memory to the limits. And then let me think. After efficiency, I switched to reliability. So different ways to improve and ensure reliability. And of course, the most famous, the most used one is testing. So talk about testing, how to, very basic. So yeah, let me say something about the whole book. I have the ambition to talk about all these different topics, but each of these topics is very, very deep. You could write entire books on each single topic. So instead, my book is quite short, and so I try to just give a feeling of each different topic, and then I suggest extra reading. As Boyan was saying, I suggest books that go into a lot more depth in each of those topics. So, for example, testing, there's lots of great books about it. So I have a very quick introduction about testing this specific class in my book. And then I have what I call monitoring, which is like runtime reliability. So how to harden your code to test its own properties while it's running. So it's a very extreme form of reliability where you have a lot of overhead. So it's only actually useful in safety critical systems where you really want to make sure that everything goes smoothly, and you really want to make sure that you know if something goes wrong. You want to realize as soon as possible that something is going bad. And so you can add all of these extra checks to your code that will check the invariants of your classes while your code is running. And then I switched to somewhat special qualities. So these qualities so far, this efficiency and reliability qualities, I think apply to most software systems. And then I switched to more specialized topics, which are thread safety and reusability. So for thread safety, of course, I talk about synchronization, mutexes, and also that's probably one of the most technical parts because I decided to go into lock-free synchronization, which is a rather specialized topic. It's how you can get more efficient data structures without using mutexes or by minimizing the use of mutual exclusion. And then I talk about reusability, so generality, that's almost an excuse to talk about generics and the new functionally oriented features in Java. So, for example, as you know, there's this trend towards more functional languages. Like mainstream languages are going towards the functional paradigm. Mainstream languages like Java and C# are integrating more functional features. And one of the advantages is that by going functional, you tend to have immutable classes, and that helps with thread safety and concurrency, which is, of course, more important than ever these days. And then that's pretty much it. So actually, there's a fun appendix, just a few pages, that's about succinctness. It's just almost like a joke chapter where I try to write the shortest possible implementation of that class that still passes like the basic specs. And as you know, that's also kind of a sport. It's a game. It's called Code golfing. Yeah. So I have a little code golfing appendix.
It's funny that you mentioned the code golfing because, it's easy to look at that and think, well, that has no real inherent value because, it kind of flies in the face of everything you're talking about, and many other principles besides. It's not very readable. It's very difficult to work with. But I have discovered kind of accidentally one of my primary languages is Python. And I was doing some code golfing for a while on codingame.com, CODINGAME. And I was just doing some competitive 5-minute rounds of code golfing. And there are so many things about Python that I learned through that, that even though I would never write a code golfing solution in production, the brevity of the solutions in code golfing showed me a lot of very interesting ways of writing code that was cleaner, more direct, more maintainable, and actually about refactoring. Because you can never write a code golf solution blind, especially if you're new to it. Like you write the solution that just works first, and then you try to optimize it down, which sounds very similar in thought process to actually what you're describing.
Yeah, and it's fun. I used to do code golfing on odd language called Awk, AWK, the Unix command line tool. And I totally agree. It's fun, and it's a kind of refactoring, and it really pushes the language to the limits. And I had to look at some C language code golfing. It was pretty crazy.
Yeah, my younger brother, he used to do that in Perl just for fun, and only thing it created were nightmares. Because that language and stuff you can do it code golfing, that's like, it hurts my head.
Yeah, Oak is also quite crazy because he also has built-in regular expressions, and you do crazy things with those.
Yeah, with Python, it's not quite as scary. C is certainly scary in code golfing because you start getting into some of those, Duffy's device and all sorts of little horrible things that technically are just, they really shouldn't exist. They do, but it's kind of as a side effect of how the language is built more than anything. It's like, oh, this is just awful.
Yeah, you're probably going to have undefined behavior everywhere, but out of luck, it may do the right thing sometimes.
Insidiously, there's a library called Loki that's written in, I believe it was C, and it has all of these things, and it leverages not necessarily undefined behavior, but it leverages bugs in the compiler, flaws in the implementations, to do some absolutely amazing things in really hideously horrendous ways.
Loki.
The name.
Okay.
I have to check that out.
Yeah, me
yes. Just don't use it in prod.
Why not? Nobody.
As soon as you change compiler versions, it's like, how's that XKCD joke go? That every there's the law that everything in your program someone's going to depend on, and there's that XKCD comic about Emacs fix. We fixed where the CPU would heat up when you hold down the space bar, and it says longtime user says, Please put it back. You just broke my workflow. My control key is really inconvenient, so I hold down the space bar and detect the minuscule change in temperature to simulate the control. And the maintainer goes, "That's horrifying." It's like, yeah, I don't care. It works for me. Just put it back. It's like,
Well, I have a fun example about the C language. I don't know if the compiler still tolerates that, but when I first studied C, like 20 or more, 20 years ago, like a friend showed me that if you have an array, so instead of writing A of 3, so A and 3 in square brackets, you could write 3 of A. The 3, then the square brackets, and A in the square brackets, and you would do exactly the same thing as A of 3. So you could.
This is just a form of Yoda programming.
I don't know.
Have you heard the term Yoda programming? It's where you invert everything, and so it's like 3 equals foo.
No, I didn't know. I didn't know.
Use the force you must.
It used to work. I didn't check recent compilers though.
So, if I understand correctly, that's writing code so wrong that it turns out to be right.
Exactly.
Oh, word. I mean, this is exactly what you mean about there's a lot of different ways to do it. Just some of them are objectively terrible.
Yeah.
Yeah, but eventually bugs will cancel each other out.
That's the theory. Well, and of course, then when you get into that, then it's hard to know. It's like, well, is this a genius solution or is this just undefined behavior? And I got darn lucky.
Mm-hmm.
Why not both?
Yeah, absolutely. Risk taking in software.
Bug Hunters Café, this is Jess. No, I'm afraid we don't have pizza after all. Yes, well, no. No, I would not call this pizza. Oh, our special today is cappuccino with almond milk. Also, guests can get 35% off any order from Manning Publications at manning.com with the coupon code PodBugHunt21. Yes, that even applies to Marco Faella's new book, Serious Good Software. You're welcome. See you soon.
This is the last time we let the unicorn cook. I now need to dispose of 17 anchovy and pineapple pizzas.
The two most divisive toppings known to mortals.
Well, our patrons are hungry, so I guess I'll break out the emergency bagel stash.
Be advised, the unicorn is in possession of a large tub of logs.
If he so much as lays one sparkle on a bagel, I'll teach him a whole new meaning of magic.
So, Marco, you teach a lot of students. I mean, that's literally what you do. And so you're obviously keenly aware that in most cases, there's a crater between the academic world of learning how to be a software engineer, how to be a developer, and then the professional world where you're actually doing it. Like there's that chasm in between the two that we're always trying to find ways to help students make it across. So especially when you're talking about some of these techniques of writing seriously good software, what are some of the considerations that people need to have in mind about these techniques when they're jumping from the small, well-defined, well-contained project of the classroom or the boot camp or the personal project over into now you're being dropped into this 10,000, 100,000 line project that someone else is handing you the requirements. How do you make that jump?
Well, how do you make that jump? You obviously need to understand the context you're put in. So I don't think there's any special magic. This time I don't have the magic answer, except that you need time to understand the context you're in. And of course, if that's your first job, it's going to take more time to figure that out. And by context, I mean, for example, that implicit balance of software qualities that your environment expects from you. So as I was saying, I think most of the time there's an implicit hidden like company coding style which puts more or less importance on different software qualities. And I don't think there's many companies that tell you explicitly what those soft constraints are. You just figure them out from your colleagues or from directly looking at the code. In the worst case, like in the worst case, you just have to look at the code you are plugging into and see how that's done and try to fit in with your new code or with the fixes or the new code or changes that you are required to make. So in best case scenario, you will have some explicit training about that. So that's, as we were saying earlier, that there should be, the more explicit it is, the better it is. But I don't think it's very common to put forward those soft constraints in the open.
So it really does kind of go back to, in many cases, reading code then is understand, well, certainly communicating with coworkers, but also reading code and understanding what are the implicit priorities that have been.
Yeah, I think so.
For me, whenever I'm working with junior developers and people who are just fresh out of college, the biggest problem is when I ask them how to do something and they freeze up. And it takes me a while to teach them that it's completely okay to say I don't know. To say, okay, I don't know, let's use Google to find out, or let's search together. Creating that atmosphere of acceptance that it's okay to not know things, that they're not going to be judged based on knowing or not knowing. Because in academia, usually you know the answer, you pass the grade, you don't know the answer, you failed the exam. And switching that into an environment that is, in my opinion, should be something that is constantly trying to nurture them and help them grow is quite different. Do you have any advice on how to overcome that, both you and Jason? Because I know you're working much more with interns and teaching people.
Yeah, it's very hard to help them in that direction in academia because we are necessarily, in some sense, like grade oriented or exam oriented. There's some content that we teach and you should know. But I get your point, and could do something fun, like we were mentioning code reading club earlier, right? So that's something that you could do as extra, no grades, no exams. It's just something that students could do voluntarily. And so at the same time, you could have a club where you, I don't know, search things together, or maybe like the instructor proposes a task and students are encouraged to find the solution online and or find different solutions and compare them. This is totally doable, but probably like an extra voluntary no grading assignment, or like a club, like a Stack Overflow club, where where you try to get the best out of it.
Well, and I think you mentioned something else a couple of times that I think relates back to this too, is iterative. The term iterative keeps coming up. Is the fact that you don't have to get it right the first time. For me, with the interns, I'm constantly emphasizing this. Got one right now who's working on, actually I got two right now working on a project, and they're on their third pass on trying to solve this. And one of them said to me the other day, it's like, wow, I feel so stupid. I said, don't. This is normal. There's a saying in the industry, you always throw the first one away, and yeah, sometimes you're going to get lucky and just nail it on the first try, but usually not. You're going to build a version and it's going to kind of sort of work, but now you understand the problem better and you go back and you can refactor it or rewrite it to work better. And it's iterative. It's over and over and over. You're tuning it. I think that's one of the best things about your book, Marco, is the fact that it's It's not, okay, here's how to do all these things on the first try. I think that's where interns and junior developers in general get stuck. Is like, well, I have to write this code right on the first try. Like, no, it can, as long as it's right at some point before the heat death of the universe, you've achieved your goal. If you have to do 100 iterations on it, that's why we have versions. That's why we have Git. That's why we have version tracking. It's like, because you're going to keep redoing it and redoing it and redoing it. That's a normal part of the process.
Yeah. I don't think any writer writes a novel on the first, like a page of a novel was not written once, right? It was written once and rewritten many times, I'm sure. The good ones, at least.
Yeah.
For me, whenever I write the program and it works on the first try, my first thought is not, oh my God, this is amazing. It's, okay, there's a bug here, but I'm not seeing it.
What did I miss? Exactly. It's a little bit like the alarm bells that go off in your head when you're working for a consultancy and you don't have any emails in your inbox. It's like, this is not a good thing. There's something horrible. I had one of my coworkers. It wasn't exactly a consultancy I was working at, but I had one of my coworkers. He's like, I got to my inbox this morning. There's no messages. What happened? What's wrong right now? It's when you don't have problems to fix from something you did, it's like, what did I do wrong?
Right, yeah. You have a certain bug rate on the code you write, so it's better if they're apparent. It's better if you see them.
That actually reminds me, going all the way back to a conversation we had, like, way back when we started doing these talks, we were talking with M. Scott Ford at Corgi Bytes, and he was talking about the value of testing, not just for success, but testing for failure. When you're writing those tests, not just testing that the output is what you're expecting, you're also testing the output is not what you're not expecting. That putting in the wrong value is going to raise the exception or return the erroneous data or whatever, that because it's so easy to write false positives. And I just spent the last 6 months of my life working on a test system for cloud images. And this was code I was refactoring, that I had inherited this from, it had been running for 7 years. And I was going through it, and I started coming across tests as I'm refactoring this thing. I started coming across tests going, wait a minute, this has never passed. But the thing is, it's always been passing implicitly because it's been failing in a way that the code was not written to detect. And so it was like throwing an exception that was being caught up here, and then it was being turned to this data down here. And by the time it reaches the test, it looks like it's passing, and it's been green for all these years, and in fact, never passed. And had been shipping with something broken for almost a decade because the tests were all written to be positive, and they were not also checking for erroneous outcome.
Wow. And it didn't affect the system so much?
Thankfully, these were things that were not catastrophic, but it just showed that some of the assumptions that were made initially in testing, and it didn't mean the person who wrote it was a terrible engineer. The person who wrote this test framework and wrote a lot of these initial tests was brilliant. His code, the fact that his code is working effectively still 10 years later, or almost 10 years later, shows that he knows what he's doing, obviously. But there's just that assumption that is so easy to make that, okay, I wrote this test, it's green, we're good, move on. And sometimes we have to question our own successes. It's like, well, it appears to be working right, but how do I know that this is actually working right? How do I know that I haven't just set myself up to make the computer lie to me?
Computers love lying. It's one of the reasons why I always write tests first and code second, because every time I do it the other way around, my tests start passing, and I'm never sure if they're lying to me or not.
You're a TDD fan.
Yeah, but not by choice, because I can't do it any other way around. It ends up catastrophically.
It's kind of funny because I'm the exact opposite. I have better luck writing the test second because they're more likely to fail. When I write them after the fact, because of my bad short-term memory, by the time I get to writing the test, I don't remember how I implemented the darn thing. So, that keeps me from being able to write the test. Because if I write the test first, I will write to pass the test. And that will cause me to inherently install bugs into my code without realizing it. But if I write the test second, I don't remember how I implemented, and I find that the testing is usually harder than the code. Because it's like, oh, it's broken. Why is it broken? And then I spend the next 2 hours debugging why it's broken.
It's your superpower.
Yeah. So it sounds like there's different ways of testing, and it's beneficial to know your own.
I won't tell you my style. It's too embarrassing. After writing this book, I can't publicly confess that I have the luxury of not writing tests, or very, very few tests, because I usually write research code, like throwaway code to do some quick experiment, publish your paper, and no one will ever look at that code. So very, very bad. Not seriously good at all.
Yeah.
Unless I want to make it seriously good, of course. Then it's gonna be.
I'm doing a presentation on infrastructure as a code, and I was listening to one podcast that very nicely presented the stages of development for infrastructure as a code. First, you use the cloud console to add things. Then you use infrastructure as a code. And then you use cloud console to add things. But you tell people you're using infrastructure as a code.
Yeah, no, I'm a card-carrying member of the Hypocrites Club. I mean, I talk about a lot of these things, and yet how often do I not write tests? I'm sitting there like, okay, this is my own code. The only person who's going to use this is me, or maybe I'm shipping a personal project and it's a GUI application. How many times I don't write tests? Because it's like, I don't want to. And it's terrible, and I know it's wrong and it's bad, but it's like, unfortunately, we have these grand aspirations. I'm going to write seriously good software, and then real life taps us on the shoulder and goes, by the way, you only have an hour to work on this, so you can ship a new feature, or you can test the things you already know are working. It's like, unfortunately, I always pick the wrong dude on the shoulder with that one. It's like, oh, I'll write the new feature. And then some user comes along and goes, hey, that thing you wrote earlier, it's not working.
I'm guilty of the same thing.
You said you start with tests.
Yeah, but sometimes when it's 2 a.m, I'm gonna just say, let's just write the code. It's totally gonna be fine. It doesn't matter if I haven't slept enough. I'm sure at this second I'm gonna create a perfect code.
How many of us push to prod? I mean, let's be honest. We commit right to prod because we're like, oh no, this is just a tiny change. This won't be a problem.
There's no way this is going to break everything.
I mean, and just to kind of drive this home, it's like that there is no such thing as a safe change. I was just yesterday adding type hits to my Python code. Just adding type hits. And I figured I was even thinking like, I can just push this up without running my unit tests. I don't need to run my unit tests. I'm not making any functional changes to the code. But I caught myself and I went, you know what? I'm running the unit tests anyway. Because it's a good habit, even though it's a complete waste of time. I'm going to sit here watching it for 2 minutes. No reason to. I'm going to run it anyway. What do you know? About half my tests were broken. And I'm going, I only added type hints. What is going on? This is Python, not C++. What is happening here? And it took me an hour to diagnose it. And I can't say I was tired. This was 11:30 in the morning. And I go through and I discovered that in the process of adding the type hints, I had at one point just copied and pasted the argument list because it was the same between 3 things, or I thought it was the same between 3 things, and I forgot that one of them had a default Boolean argument that was different than the other 2. So I changed the default true to a default false. And it broke everything. And had I pushed that to production, it would have broken all of our tests in prod. And it's like, oh my gosh. So it's like, even when you think all I did was I just changed one line of documentation. I just added the type hint. I just, fixed that one little flaw with the math. I don't need to test it. Yes, you do. Yes, you
Hubris.
do.
Greatest
Horrible things
programmers.
hide in little changes.
Yeah.
So one thing we always like to ask on these conversations is, what is one of the weirdest bugs you've ever encountered, especially ones you've caused, because we like talking about mistakes in code, obviously.
So it's not very, I don't know, it's not very special or funny, but it just happened to me like a few weeks ago. And as I said, I don't get to program so much. I do program from time to time for research projects, but instead I made this mistake while preparing a final exam. So I have these final exams where I give them some Java code and I ask them to draw, like on paper, draw the memory layout of a little piece of code. And this usually has to do with internal classes and that kind of stuff. So they have to, because Java is quite special about different ways you can put classes inside each other. And so they have to draw this little picture. And so when I was grading this, maybe 20 students took this final exam, I was grading them, and everyone had different pictures. And I got suspicious, and I went back to my code, and I realized, so I had never tried it. You know, I was in a rush, so I came up with these little classes with some internal classes and so on. And I hadn't tried it, and I had created an infinite loop of object creation. Like there were no loops in it, there were no loops, but there was like class A with the reference to an internal class B, and then B had the reference to A, something like that. Which, if you just created one object of type A, it would like just by constructing it, it would go into an infinite loop, like an infinite mutual recursion of constructors to be more precise. So basically what I was asking them to draw an infinite picture of infinitely many objects. It would have been great if some student would have stopped. I mean, this is a final exam you take in a classroom. It would have been so much fun if someone had stopped and told me, "Hey, can I get more paper?" So, yeah, go ahead. And then after 2 minutes, can I get more paper? This memory layout you're asking is really big. And, but nobody coded. So yeah,
Oh my gosh.
I ended up basically giving extra credit to everyone because it was my mistake, obviously. But
Oh my gosh.
too bad nobody coded.
It's like, excuse me, professor, why don't we have a ream of paper on our desk? You're going to need it. And 10 points to the student who can tell me why.
Yeah, exactly. It would have been fun to give it on purpose and see.
Yeah. Today we're going to be learning about undefined behavior in humans. This is literally undefined behavior. Yeah.
Yeah, poor students.
Absolutely.
It's been an absolute blast having you here, and reading your book has been amazing. I really love what you have done, and I really hope you keep writing more books, because I'm sure next one is going to be even more amazing.
Wow, thank you so much. I love books, and unfortunately, sooner or later, I might write another one. I might fall for it eventually.
Well, hey, maybe you should do a 7-volume series and go on to each one of your practices in depth or something.
Different topic next time. I'm thinking about probability and video games.
Ooh,
how about that?
That sounds fascinating.
Yeah,
and quite interesting.
Thinking about it. Maybe one day.
I have one last question. What's your favorite fiction book?
Fiction book.
I mean, I see Dune on the shelf.
Yeah, I picked it. I read it when I was probably a teenager. Then I watched the movie. I loved it. I loved the new movie, and so I got the book out. But I didn't find the time or strength to reread it. I read a lot of sci-fi, and there would be some in the sci-fi area, it would be something by Asimov, I would say. Nothing very original. But outside of sci-fi, I like John Barth. For example, The Floating Opera, and also another book by John Barth, I think. Maybe I should ask the unicorn about the other title, but check something by John Barth. Oh,
Yeah.
yeah, you also have like an oldish edition.
Yeah. I got this from a friend in New York. It's
I
so
don't
hard
know this
to
one.
find his books. He
I don't
found
know.
in a secondhand store.
Oh yeah, the other one by the same author, and it's called The End of the Road. It's quite famous, I think.
I love the fact that you guys just happened to bring your John Barth books to the cafe. And
Yeah, I always walk with my John Barth book.
Yeah. I mean, don't you, Jason?
Don't you walk with your favorite book by your side?
Well, I'm not entirely inaccurate. I usually keep a book in my laptop bag, whatever I'm reading presently, and then between tasks. So I'll read a paragraph or two. Right now, I'm reading through "Kill It with Fire" by Marianne Bellotti, which I've brought up a few times. So I'm still reading through that. It's a nonfiction. It's about refactoring legacy code, but I
Serious stuff.
think I'm rereading The Lord of the Rings at the moment. I just haven't I actually haven't sat down and read in about 6 months because I've been running around like a chicken with a bad haircut, to abuse the phrase.
Did you guys watch Foundation, the TV show?
That was one of my favorite book series when I was young. I absolutely love how it connected everything in Asimov's books, and it was super epic, but I did not dare to watch the series. I was super scared. Like, I have very good childhood memories of this, so I'm just not gonna watch it.
Okay, I won't insist then. It's okay. It's pretty good, I think.
For reals?
Yeah, most of it.
Most of it.
I might give it a try, but I think I'll probably just reread the book.
Okay.
Now I just have to wonder what it's going to be like when anyone does a movie adaptation on us.
I have already booked Morgan Freeman for myself. So
Bojan Militic, played by Morgan Freeman.
yeah. I already sound like him.
Hey, and knowing me, I'll probably be played by Martin Short.
I hope Benedict Cumberbatch would be my pick for me.
Oh, I can see that. That would be fantastic.
Here.
Yeah. Oh yes, yeah. You can do that.
Yeah, you do look like.
Yeah, just a little bit. My best friend looks surprisingly like Sean Astin. Well, this has been an absolute pleasure, Marco. Thank you so much for joining us.
Thank you for having me.
And smelling pizza and knowing there isn't any there. Do you know any good pizza places that we can find some real pizza? Because I'm getting hungry.
Around here, like in Naples,
Yeah, we can just pop through the portal and
come and you should go to Pizza Con near my house. A very strange name. It translates to pizza with, and that's it. Pizza with, Pizza Con.
Pizza Con. So is it pizza with whoever you want to bring, or it's pizza with whatever side dish they're offering that day?
We're all wondering that. Nobody knows.
Jason,
well,
it's a probabilistic pizza.
Yes, pizza with.
Oh,
That's it. Well,
either that or it's a context manager. That's the other possibility. It could be a context manager.
yeah.
In any case, let's go find out. There's a portal over there, and we can just go because the smell of pizza.
Let's move from tea to pizza.
Yeah,
No, and no pineapple, please.
Oh, okay. I like pineapple well enough, but I'm not a huge fan of the anchovies.
All right.
And we'll continue this discussion about fiction over there, I'm sure.
Bug Hunters Café, this is Jess. Yes, we're still open 24/7 at Bug Hunters Café. You can also find us on Twitter as Bug Hunters Café. Our music is provided by audionautics.com. We have a link on our website. Our giveaway? Yes, you can win a copy of Seriously Good Software by Marco Faella. For your chance to win, just retweet our Twitter post about it, and then follow Bug Hunters Café for the announcement of the winner in a few weeks. What do you mean, the other giveaway? You won 17 cold pineapple and anchovy pizzas? Ma'am, if you can't pick those up today, I will throw in a free pizza oven. Oh, we definitely don't need it anymore. You could say we fired our chef.
Oh no, from the bottom of my heart. Thank you.
Artistic censorship? I'll show you artistic censorship.